Welcome back to another Regents Physics topic overview. Today we're going to be talking about Newton's second law. So let's get right into it. Starting off with our facts here for Newton's second law. A more general fact for forces. We have for all forces other than the force of Earth on objects must be in contact in order to experience said force. So again, every force is a contact force, essentially besides Fg. Then object acceleration is in the direction in which forces are unbalanced. That means wherever the force is greater on an object, that direction is the acceleration for that object, and we're going to look at that in these examples. Net force, that's going to be used interchangeably with unbalanced force, and you'll see that in multiple choice questions or just in questions in general. And the unbalanced force in the direction of acceleration, same exact idea as the bullet from earlier. Now your equation for this. Unbalanced forces equal F net equal ma. On the Regents reference table, F net equals ma is there. It's ran out as A is equal to F net over m. Then actually solving these problems, you're going to have a two-step solving process. Draw a free body diagram first. If they've given you, say, the numbers of the forces and given you the arrows from that, you don't have to draw the free body diagram since it's basically given to you with numbers instead of the actual names of forces. And then you're going to write two equations, one for Newton's second law in each direction. So you're going to start off with F net equals ma, because that's the equation from the reference table. Then whatever direction I'm moving, if you're moving in a horizontal direction, you'll use left and right forces. If you're moving up and down, you use up and down forces. And note, you're never going to get a negative force, so you're going to always start off with the force that's in the direction of acceleration. In other words, you're going to start off with the force that is greater first. So say if you're accelerating to the right, you're going to do right minus left forces. If you're accelerating down, you'll do down minus up forces equal to ma. So let's get into our examples. All right, so looking at example 1, for any of the examples here and the facts that I just went over, they're going to be in the description down below, linked as Google Docs. So you can go there right now, grab them, and follow along for the rest of the video. So for this situation, we have four forces that act concurrently at the same time at an 8 kilogram block on a horizontal surface as shown in the diagram below. The reason why it is 8 kilograms, we have here an 80 Newton force going downwards. I know that's going to be my weight, or Fg. I know Fg is equal to mg from earlier stuff here in the unit. I then can do 80 newtons divided by g, which we use as 10 newtons per kilogram, and end up with my 8 kilogram block there. So now just looking at the direction of acceleration. We're going to justify our answer, and when we do that, we start off with our evidence, our fact of physics, then go with our reasoning since this is happening in a situation, and then make my claim based on the evidence and the reasoning. So my evidence here should be a fact from the fact on the previous slide. Again, if you don't have that, either go back, take a screenshot, or it's going to be all in the description down below. So for this situation, I can say that an object's acceleration is in the direction in which forces are unbalanced. That's going to be my evidence, my fact of physics. Then I'm going to explain my reasoning, since what is happening in this diagram here. I'm going to have more force to the left than to the right. That means to the left, I have unbalanced forces, or that's the direction in which forces are unbalanced for the situation. Since forces are unbalanced for the block to the left, I can then make my claim that the acceleration for the block should also be to the left. So the block's acceleration will also be to the left. This is going to help me make my Newton's second law equation in the next part of this question. So let's move into part B. All right, so looking at part B of this example, we're going to calculate the magnitude of the block's acceleration, showing all work, including the equation and substitution with units. So when we see magnitude, that just means that we're looking for the number of the acceleration with obviously the units, but we're not worrying about whether it's positive or negative. And showing all work, including the equation and substitution with units, means we're going to start off with our equation. We can write down the side what the mass is with the units, but if you're just going to, just to be safe, plug in everything with the units, then you're going to get full credit if this were a part 2 on the Regents. Starting off here, I have forces, and I want to find acceleration. That means I'm going to end up using F net equals ma. I then know that F net is made up of my forces in the horizontal direction, my left and right forces. We figured out in part A that the direction of my acceleration was to the left. So I'm going to start off here with left forces minus right forces are equal to ma. Then I actually want to find the acceleration on the right side of the equation that is currently attached to m. Since I want a all by itself on one side of the equation and it's attached to m by multiplication, I'm going to do the opposite operation and divide out m on both sides of the equation, being left with left forces minus right forces over the mass is equal to my acceleration. Now I can start plugging in numbers. I know my left force is 120 newtons. I know my right force is 40 newtons. That is over the mass of 8 kilograms, and that is equal to my acceleration A. Then I'm just going to do the subtraction on top. 120 minus 40, that's going to be 80 over my 8 kilograms. 80 divided by 8 is going to give me 10. Units can be newtons per kilogram, but we know that acceleration is going to be in meters per second per second. They're the same exact thing. So I should have here 10 meters per second, or meters per second squared as my acceleration for this situation. So let's now move into example number 2. All right, so moving into example number 2, we have two forces, F1 and F2, are applied to a block on a frictionless horizontal surface as shown below. F1 here is 10 newtons to the left, and F2 is 5 newtons to the right. So what is the direction of the block's acceleration? And we're going to justify our answer. So again, very much like earlier, this is very similar to the example in number 1. We are going to have more force here to the left. We're going to start off here with our evidence. We know that an object's acceleration is in the direction in which forces are unbalanced. So that's going to be my evidence or my fact of physics. Then I'm going to have my reason here. What's happening in this situation? Since we have more force to the left than we have to the right, we are going to have unbalanced forces to the left. So since this object's or the block's forces are unbalanced to the left, we know that then my acceleration is also going to be directed to the left as well. So then that's going to lead us into creating our Newton's second law equation in part B. So let's move into part B. All right, so looking at part B of this example, if the magnitude of the block's acceleration is 2 meters per second, what is the mass of the block? Again, we're going to show our work, including the equation and substitution with units. So again, the equation that I'm going to end up using, if I have forces, I have an acceleration, I'm looking for mass. The only equation I can end up using here is F net equals ma. So I'm going to start off with that. Then I know my net force is made up here of my left and right forces, since that's where I'm moving on a horizontal surface. I know that my acceleration is to the left because that's where the greater force, or that's the direction in which forces are unbalanced. So I'm going to have here left forces minus right forces are equal to ma. And right now what I'm going to do, I know my left force is F1, I know left force is F2. This is like if I had a free body diagram and I was looking at, say, FF and FA. I'm just going to put those in as variables. So my left force F1 minus my right force F2 is equal to ma. Now I'm going to solve what they're asking me to solve for. They asked me to solve for the mass of the block. That is currently attached to acceleration by multiplication. So I'm going to do the opposite operation and divide out acceleration on both sides of the equation and be left with F1 minus F2 over A is equal to my mass. Now I can plug everything in because I've done all my algebra. I know what my forces are going to be in each place. F1 again, that's 10 newtons, minus F2, that's 5 newtons, over my acceleration, which is given to me as 2 meters per second. 10 minus 5, that's 5 newtons, over 2 meters per second, equal to my mass. 5 over 2, that's going to be 2.5, and then I know that the units for mass are kilograms. So that's going to be my answer, 2.5 0.5 kilograms is going to be equal to the mass of this block. So I hope these examples were helpful, and see you guys in class.